Here we go for today. React tooling, yay! So we are going to just talk about Create React App, demonstrate how to boilerplate a React application with this tool, what it hooks up, what it gives us, and there's quite a bit in there that we can kind of strip out and delete, and then to get us ready for where we want to be every time we do this. So, and that, when we go over that, that's going to be kind of personal choice and depending on the project, of course. But I'll show you kind of what I do and where I start with each application and why I delete the things that I remove out of there. Then we'll jump into prop types. So we're going to learn, this is a built-in React type check system. So we're going to learn about that, what type checking is, why it's important, why we would want to have type checking in our application, and how to integrate that into a React application. All right, so with that being said, let's take a look at Create React App. So this one, this is an interesting one because we Create React App 2.0 was released 4-ish months ago, and there are a couple potential bugs with when you use Create React App now. The two big ones that we have run into, we've documented here. So the first, if you get this error, Create React App requires Node 8 or higher, then you're not using a compatible version of Node. And these are the steps to fix that. And then there's also this yarn start error that could be happening. And I actually ran into this last week or 2 weeks ago. I don't remember what I was building, but I actually ran into this. So I came here to Training Kit to look up how to fix it. You can just follow all the steps here. That's what I ended up doing. Or you can do this, which is kind of a shortcut. So you can go either way. You can follow all these steps or just do the shortcut for that one project. Okay, with that being said, let's take a look at starting a React application with Create React App, or you'll see it CRA for short quite often. Okay, so here's my terminal, and I'm going to go to the path that I want to put my new application on. So we'll go into development. Maybe I'm going into project, something like that. That looks like a good place for a project. Perfect. So there's a couple different ways that we can run Create React App, and they're noted here. Or maybe we took the other ways out and we're just using yarn. Yeah, I think we did. Okay, yeah, so we're just using this now. So we'll go with yarn space create space React App, and then the name of your application. So I want you to open your terminal and run this command here. So I'm going to go yarn create React App, and whatever you want to name it. So I'll name this Dumbo. I don't know. How about Dumbo? Yeah. Has Dumbo come out yet? I don't remember if that's been released. So then Create React App runs and runs all the scripts and does all the things. Now, the last week, when you cloned a project down from GitHub, you noticed that you had to run yarn install and yarn start to get a project started, right? Well, this, running Create React App, actually runs yarn install for you. Let's see if we can find where. So here's all the dependencies. So it's already installed all of our dependencies for this project. So when you run Create React App, you don't need to run yarn install. So instead, it tells you exactly what to do here. So here are the 4 commands that are built in that you can run: yarn start, yarn build, test, and eject. Then it tells you, gives you suggestion on how to work on your project. So we cd into our project here, and then run yarn start. And there we go, pulls up our project. Yay, we started a project. Okay, this project has been bootstrapped by Create React App. So who can tell me what what that term means, bootstrapping an application? Nope, not quite. It is actually different than the Bootstrap library. Yeah, boilerplated. So we've got a project that's boilerplated. Okay, what does boilerplating mean? What does boilerplated or bootstrapping mean? I guess, I'm sorry, yes, you're right. So I should have used the term boilerplated, not bootstrapping. I should have used this term. Sorry, rewind. What does boilerplating a React application mean? Yeah, it's kind of pre-made code. It's a pre-made template to get us up and running quicker. John, make sure you CD'd into your, looks like you did. CD'd into it. Yeah, I like this word, packaging. It's pre-made packaging, pre-made template for a React application. Downloading the necessary tools to start, removing unneeded things. Not quite, we're gonna do that manually in just a minute. Yeah, having everything pre-installed, ready to go. Yeah, bare bones app, ooh, I like this. So having a boilerplate, yeah, boilerplating is pre-made package, and it gives us a bare bones application that we can just start working on from there. Now, the reason we want to have something like this is because without having this kind of boilerplate for us, there's actually a lot of work that would go into setting up a React application. And you have to bring in a lot of tools, and you have to do a lot of setup. And yeah, it's all this repetitive stuff that we don't want to redo every single time. So there was actually a problem with this when React first came out. There was so much setup that went into just getting to your starting point that developers experienced what was called JavaScript tool fatigue. You can research that, and it's a rabbit hole of never-ending articles on this horrible thing. So luckily, we now have Create React App, and the process of getting started with React is way easier and streamlined because of the boilerplated code that is given to us just by running that command in our terminal. Yeah, so great job. Good answers here. Let's take a look at what exactly is boilerplated for us in this new project that we just opened up. Okay, so I need to do this, and then I can go to my terminal. Terminal, where'd you go? There we go. And open this project up. Okay, so here is Project Dumbo. This is the project we just bootstrapped or just boilerplated with Create React App. So let's take a look at what we have here. This is going to look very familiar because all of our projects have been started with Create React App. So we've got this yarn lock file. We don't ever touch this. You never do anything in the yarn lock. This just tells if you were to push this project up to GitHub and then pull it down on a different computer, or on a server and get it hosted and running, that where you pull it down to and you run yarn install, it will just make sure that every dependency of your project gets installed in the exact same way, in the exact same order, and the exact same versions every single time. So no matter where you pull this project down to in the world, you're always going to install the dependencies in the exact same order. Everything's going to be set up the same. In fact, that's why we have yarn. So as you've realized now, we have yarn and NPM, right? They're both different package management systems that you can use to manage your dependencies for a project. NPM came first, but there was a lot of problems, not a lot of problems, but enough problems that people were having and experiencing by the build order not always being consistent in on different computers and different systems. So this is kind of the reason that we even have yarn. Also, yarn is a lot faster. NPM's made really good strides. I don't know what the benchmarks are between the two anymore, but yarn solved a couple problems that NPM was having. NPM has since caught up and solved those problems in their system too. But we use yarn in this class because it's from the Facebook team, and so it just goes right along with using React. So that's the yarn lock file. The README gives you all the instructions for the project, gives you some good resources if you need to go in and study some things, learn about how this was put together. Our package JSON looks familiar. These are the same ones that we have been, this is the same look that we've been using in our projects. So this just lists our dependencies. You can run, this is where you can define what scripts you want to run from the terminal. So remember, if we look back at the terminal, oh no, I can't go up and down. Remember that list of commands? You can probably see it in yours, but they're all right here. So these are the commands you can run now with yarn. So yarn start, yarn build, yarn test, etc. Git ignore just tells your computer which files and directories to ignore when you push this code to GitHub. So it won't push any DS store files, it won't push your node modules directory because this directory is huge and has just a ton of code. So you don't want to push all of that to GitHub every time. Okay, so that's just kind of the basic stuff. Now let's take a look at our source folder. So you've noticed that there's quite a bit of stuff going on here, a lot more than what we're used to. So let's just take a look at these one at a time. Let's go to our index.js. Oh, we don't have, oh, there it is, index.js, okay. What do you notice in here that we're not used to? What do you see here that we normally haven't seen? Let me slide this over a bit. Yeah, service worker. Good question, Oscar. So last week when we started, we decided not to do threads, but we're going to do questions on this main page. Number one, since we're all split up into different sprints now, there's less chatter on this main page. So this is specifically for these lessons. And number two, we can do something like this, like Mary asked this question, and now Ben can come in here on a thread for that specific question and answer the question here. So if we had started a question thread, then you can't thread inside threads, unfortunately. So I have found that this is a really good pattern to help PMs or other students come answer questions. Okay, yeah, service worker. We see this whole thing happening here. So let's take a look at this one line at a time. We're importing everything. We've got the asterisks of the wildcard here. So we're porting everything as service worker from this file right here, serviceworker.js. And then we're calling an unregister function off of this object that we've imported. And we've got this here that says if you want your app to work offline and load faster, you can change unregistered to register below. But this comes with some pitfalls. So the idea behind this service worker stuff is this gives us the ability to make what's called progressive web apps. And progressive web apps do a couple things for you. So number one, it uses service workers to run JavaScript when you don't have internet. And so you can run your project, you can cache your data, and you can still run your entire project even if you're not connected to the internet. Kind of a cool thing, but again, comes with some pitfalls that you can study up on this link here. Progressive web apps are also, you can go to the web page, the website in your browser, whether you're on your computer or your phone, and you can actually download that application as a desktop application or a mobile application, and it works. So this is a way that you can actually make like mobile apps. You build one React application that works in the browser and then also works as a mobile application on a tablet or a phone, and then also works as a desktop application. So some really powerful stuff going on here. Unless you are specifically making a progressive web app, we can just delete all of this code. So that's my first step, is coming into index.js and getting rid of service worker stuff. And then that means I can come here and delete that file. Okay, so the rest of this looks pretty normal. We're getting our CSS, we're getting our app component, rendering our app component. So let's go check out app.js. And the rest of this we should be pretty used to this by now. So we've just got some JSS that's rendering everything that we see right here. So this is being rendered from our app.js file. Now, you're probably not starting a React application to build this. So generally, we come in here and just kind of strip everything out of here. So let's take a look, before we delete this, let's take a look at what we're deleting, if there's anything imported from here into this file that we're deleting. So I think the only thing I see is the logo. So we're getting React, we're getting component, and then logo. So if we delete this header tag and this logo import, then we can go to this logo SVG and delete that file as well. Okay, then we've just got a basic application, empty. If I, it's not started up. Darn start. Oh, I probably should save my files too. Save all. Okay, yep, there we go. Now it's all blank. We're ready to get started. But not quite. There's one more thing to look at. What else is here in this project that we haven't seen before? Yeah, the test file. Good. So let's take a look at this test file. And I'll just show you how to run this real quick and what it does. We won't get into testing in this unit, but that will come in the backend unit. But it's good to see and kind of recognize what's going on. So remember back in this package.json file, we had this yarn test script that we can run. So we've got this test script, which means we can come here to our terminal. And let's see, I'm going to duplicate my tab, so it should still be, yep, still on my file there. Okay, so I'm just going to run yarn test and see what happens here. Okay, so you saw for a second that this was yellow, and it said that it was running a test, and from my test file here. And then we get a bunch of stats about our application. So our test passed. We had one test. We didn't do any snapshots. It took that much time to run. And then we have a bunch of commands that we can run from here to rerun any of these tests or specific tests. Like if you only want to run your failed tests, then you press A, press Q to quit watch mode. So now this terminal window is actually still running and waiting for me to push one of these buttons to, like I could push A and run that test again. We can push F and run failed test, but there's no failed tests found. So a lot of stuff you can do. Let's see, press F to quit only failed tests mode. Okay, so now we're back to running all of our tests. So let's see what this looks like if we break our test, if our test fails. So I'm going to come in here and create element div, render app. Let's do, let's see, how can we break this without breaking the JavaScript? Can we just do something like that? No, it'll still render without crashing. Okay, so here's a failed test. So what happened was we just broke the JavaScript basically. But yeah, but now you can see what a failed test looks like here. So then you see what test failed, renders without crashing. That's this text right here. So renders without crashing failed. So you'll read the error, and then go fix the test. Yay for tests. Tests are fun. And I'm glad I don't have to teach them. That's for Luis. Haha. Evil laugh time. Wahahaha. Okay, so some questions that came in. Let's take a look at these. How does get ignore really work? Looks like there's some good questions here. Let's see. Yeah, I think this is the point here, so that we're not pushing any of these things to GitHub. So one of the big things is node modules. We don't want to push this huge amount of code to GitHub. Then every time you go to clone down that project on a different computer, or maybe you needed a fresh start, it would take a long time to download that project because you'd have this huge directory to download. So instead, we ignored node modules within our Git, and we just run yarn install after we clone a project down. The other thing too is, let's say you had some like API secrets, or so an API secret is basically a passcode for you to work with a locked down API, and you have to send that passcode with your requests, or so that the API can authenticate you. Then you would have a .env file. So we would say, no, not in node modules. Close node modules. We want it in Dumbo. New file. There we go. We'd say .env, and we would have like AWS secret is what it's called. And then it would be some weird string without spaces, but I keep typing spaces for some reason. So you don't want to push this to GitHub because you don't want someone to find it in your GitHub repositories. So then we would go into git ignore and we would say .env. It's kind of an environment file, which is why we, oh look, so here, we've already got DNV, or env, we've already got env files listed here. So those are kind of the two big points of git ignore. Huge amounts of code and node modules, and then your .ems. And then the third one is like dsstore is our specific files, hidden files on Macs. So if you have a Mac and you don't have dsstore in your git ignore, you're going to notice a lot of weird dsstore files in your GitHub repository. Also, if you are working in like VS Code or some other editor that has like config files, then you want to ignore all those config files for your editor. So, whew, there we go. Yeah, that is git ignore. Okay, great question. Let's see what else we have here. So component, what is this? Let's see. Oh yeah. Let's talk about that. I know, I was trying to figure out what we were talking about. So what is this? So remember when we talked about classes, we said that a class component extends the React component class. Well, instead of writing React.component, you can actually just import component on its own, like this, and do that. There's really no benefit either way. This class is already coming in with this huge React object, so you don't need to do this. Some people just like to be a little bit more explicit on what this file is relying on. Right here at the top for different reasons, so you can do that. This is technically more typing than just writing React.component, so I tend to just do React.component. But it's up to you. Good question. Sorry, yeah, I saw that and I was like, okay, don't forget to cover component, and then we just skipped right over it, so my bad. Let's see, there was last question that came in here. So is it required? No, you don't need to have this. You could absolutely pull it out like that and just do React.component like we learned last week. So it's totally up to you however you want to do that. There's really no difference either way. Okay, this looks like it was answered. You run yarn test to start your tests, and you'll get into how to build those and how to build them effectively and why we build tests into our applications. Tests are very important. They can be fun. They're often looked down on kind of in development. So it's something that every developer knows needs to be done because it just helps fix a lot or catch a lot of bugs before you push code to production. But it's one of those tedious things. Like most developers would rather just be building out something new and fun and figuring out the logic. Testing often gets in the way of that because you build out your fun new thing, but then you have to go build out all the tests for it. Yeah, so you'll see. You'll be there soon. You will understand. Steve says, could we realistically run all of our apps without removing any of these files? Yep, absolutely. Cool. Let's take a 5er, and then we'll be back and jump into prop types. Great questions. I'll see you back in a few minutes. Okay, come on back to your computers. And let's get started with prop types. So this is the project we're going to be working off of. Oh, it's over here. Okay, so we've got that forked. So this is the project we're going to be working off of. And let me start up a live session. Creating session. That, and then we're good to go. Yay, Pokemon. This is my son's really into Pokemon right now. It's been fun. Okay, let's just kind of poke around here and see how this app is set up and what we have, and then we'll talk about prop types. So first, we want to take a look at the data that we have. So we've got an array of objects, and each object obviously is a Pokemon with quite a bit of data on here. So later, if you want to just kind of play around with some code, you can come here and build out these Pokemon cards and put some good data on here. We're going to build it out we're not going to do a lot of work in the UI today. We're basically going to be focused on the code part of it. So yeah, you can come here and do a little bit more if you would like. Okay, so there's our data. Then we've got our index.js, and that looks pretty normal. We've got our app.js. So tell me about app.js. What do you notice here inside our app component? Nothing tricky, just tell me what you know about this app. Okay, yeah, we're importing our data. Good. Yep, we've got some state. Perfect. So this is, since we have data on a state object, that means we wanted to do a class component. Good. Yes, but that is happening in a different component. So to get that data down to a different component, we're passing props down to our Pokemon component. Nice. Good, good. Yeah, I think that's about it. So we've got our data coming in, being set to the state object, and then being passed down to Pokemon as props.pokemon. So let's go into Pokemon and see where props.pokemon is being used. So we've got the props object coming in, we're console logging our props object, and then we're mapping over our Pokemon data and displaying a card, a Pokemon card for each Pokemon in the array. And then this is just the image and the H3, the header here. Okay, awesome. So because we are passing props down to this component, this is where we can use prop types. So prop types is a type checking system that's built into React. Who can tell me what type checking is and why we would want to use it in an application like this? I try hard. Yeah, this is a great way to kind of demonstrate what type checking does. It checks the types and making sure that our data is correct. So if we're expecting a string, we want to make sure that a string comes into our component. We don't want to, for example, Pokemon.name is a string, right? If we go to our data and we look at the name, this is a string. Well, we wouldn't want this to end up being an object, right? We don't want to try and display an object here. So if we come into our data and we say something like this, then we get an error. So we want to make sure that our data, what we expect, is actually coming into this component. Okay, good. What else we got? Yeah, helps in debugging a lot. If you are expecting the Pokemon name to be a string, but it's coming to your component as an object, and then you run into some errors, it can be hard to figure out where to start sometimes. So type checking will give us warnings when something is coming to our component incorrectly, and we'll say, hey, by the way, I know you were expecting a string, but this is actually what the component received. It received an object, or received an array, or a number, something like that. Yeah, absolutely. So we just saw this happen, right? And if an ID, or if a component is expecting a number, but a string is passed, it can break the code. So for example, we had this key. Oh wait, where were we breaking the code? Probably here is where we broke it. So we need to pass a string to this alt tag here, and we passed an object to it. And we can't put an object on this attribute. Yeah, perfect. Okay, so let's take a look at how we do this in React. So the best place to look is the docs. Prop types. Here we go. Type checking with prop types. Let's see what the docs have to say. This used to be, prop types used to be its own library, but since React 15.5, it was moved internally to, or excuse me, it used to be internal in React, and now it's moved to a different library. Sorry, I got that backwards in my mind. So if we want to use prop types, we actually have to go add it as a dependency. Excuse me. I should have muted my mic for that, but it just snuck up on me and I didn't have time. Okay, so we're adding a dependency here. Oh, why did we do that? We don't want that one. So let's come in and add prop dash types. And everything breaks. Yes, reload. Okay. Let's see. I'll try that again. Prop types. That worked better. That was awkward. That was weird. All right. So you'll notice when we add a dependency that our package.json has changed. So that's now added as a dependency in our project. So we're going to save everything here. And now we're going to go into our Pokemon component, and we're going to import prop types from, oh, let's see, let's do, yeah, prop types from prop dash types. The naming on this gets a little confusing, I'm sorry. I'm going to show you I'm going to show you the convention. It's a little confusing, but I think you'll pick it up pretty quick. This is really, the way I'm going to show you is really the only way that you'll ever see it happen, so we just have to get used to that. Hide notifications, there we go. Okay, so we've added this now as a dependency. So what do we do with it? Well, we import prop types, and we can start type checking the props that are coming into any component by adding an object to the prop types property of our component. Okay, so if we're in Pokemon, we're going to say Pokemon.proptypes equals some object. So we have Pokemon. We're going to say .proptypes, but not capitalized. This is the confusing part. So we have lowercase prop types, uppercase prop types, and kebab case prop types here. This is the only place you'll use prop dash types is when you import it. This is the only place you'll use the lowercase is when you're building the property on the component. And then the rest of the time you'll be using this uppercase prop types object here. So as you can see, we've got a good example of how we start setting this up, right? So what is the prop that's coming into this component here? What prop are we receiving here? Pokemon, yeah. And what is Pokemon? We have props.Pokemon, but what is it? What is its type? Nah, it's not an object. Take a look, we're console logging it. Go look on your console logger, go look in your React tools, see what's coming in. Yeah, it's an array. Yep, so let's take a look at the console here. Props is an object, but props.Pokemon is an array. So let's come down here to our prop types and let's tell our component that Pokemon, we're going to receive a prop called Pokemon, and then it's going to be an array. So if we come here, we've got, I'm going to give you this link here because this gives you all the different prop types that you can use in this object. Array of object, yeah. Okay, so let's take a look at this. You can declare that a prop is a specific JavaScript type. By default, these are all optional. So we can say that a prop is an array, a Boolean, function, number, string, object, string, or symbol. So we have an array coming in. So we're going to do capitalized prop types dot array. Like this. Oh, not array of. So many weird things happening. Okay, there we go. Okay, good. Let me lower this. Why is this spread out over there? I do not like these changes. I do not like them, Sam, I am. Okay, so I'm going to open this up here and open up my console so we can see if anything is happening. We can take a look at what's going on in the console here. A little bit easier than we can in this console. All right, right now we get no errors, right? We told this component to expect a prop called Pokemon that's going to be an array. So let's call this an object and just see what happens if there's a discrepancy here. So we're going to say object. So we're telling it to expect an object for Pokemon, but we're feeding it an array. Aha, so now we get a warning. So warning, failed prop type, invalid prop Pokemon of type array supplied to Pokemon, expected object. So this seems a little bit backwards, but let's just talk through how to read this error so that you know when you see this warning, you know, sorry, I shouldn't say how to read this error because it's not an error. An error would actually break the browser and wouldn't let the JavaScript engine continue to evaluate code. So they don't throw an error for these. These are just warnings. So we get this warning, and it said an invalid prop Pokemon. So in Pokemon, in our Pokemon component, the prop.Pokemon is invalid. So we know which component, we know which prop, then we can tell exactly what the warning is, what happened. So type array was supplied. So Pokemon is receiving an array for props.Pokemon, but it's expecting an object, because that's what we told prop types. So that's kind of how you read this. The one that comes at the end is what you told it to expect, but the one here is what was supplied to your component. And then this is the prop that received that warning. All right, so we'll come back here and we'll change that back and we'll refresh, make sure that we're not getting any more warnings. Yay, we fixed our warning. We're so good. Okay, that's the only prop that's coming into this component. So I guess we're done for the day. Have a great day, everyone. See ya. Just kidding. We're actually going to build this out quite a bit more, because prop types gives us one more big advantage. So not only does it do a lot of type checking for us, but it's kind of a way to document what's happening in this component. Prop types tell a story for the component that they're defined on. And what I mean by that is, if you build this component out and 3 months later you need to come change something or build something else or fix a problem that occurred, or if another developer needs to come in after you finish this and work on this component or even reuse this somewhere, imagine a large component that's like 200-300 lines long. That's pretty normal in React. So you come to this file, it's 200-300 lines long. You're trying to reuse it in a different place in your application. In order to reuse it, you have to know what props it's expecting, right? You have to know which props it needs, what the types are, what kind of data to feed this component. Otherwise, you're going to run into problems and it'll break. It'll either throw an error or it could just not display correctly. So there's two ways to figure out what this component needs. The first is to come into the JSX and go through here line by line and figure out what's being rendered and where that data is coming from. That's really tedious. I've worked in that kind of situation before, and it's not fun. A better way to learn about this component is coming to this prop types object. So I can come to this prop types object and I can say, okay, if I want to reuse this component somewhere, or if I want to work on this component and not break it, I need to make sure to have a prop called Pokemon. I can give a Pokemon array to this component. So this is good to have this, but it's just a start. This still doesn't really help document well what's going on here, because what's this an array of? Is it numbers? Is it objects? Is it strings? We don't know. So this tells us that we have a Pokemon array coming into this component, but it doesn't really tell us much more beyond that. So we're going to learn during the rest of this lecture how to make this object really tell a good story about this component. So with that being said, let's take a look at Slack, see if there's any questions, and then we'll go to break, and then we'll come back and learn about all that good stuff. Okay, cool, no questions. Let's take a break. I'll see you back in 5. Okay. Come on back to your seats. This is really nice. You are the first cohort I've done 3 breaks with. I used to just do 2, like every 40, 45 minutes or so. So this has been, I like breaking this up. Okay, prop types, telling the story. What is going on inside Pokemon? What data do we need to get this component running? So let's come up here and see if there's anything that will help us tell the story of this Pokemon data a little bit better. So we can do any kind of type like this. But if we look down here, we see that we can specify an array of a certain type. So let's try this. Let's try prop types.array of, and then give a new prop type inside this function. So we're going to come back here and we're going to say dot array of, and this is a function. So as you can see in your helper here, this is another type. So we're going to have another type inside here. So we'll do prop types again, capital P, capital T. What is in our prop types array? What is this an array of? Objects, yes, of our Pokemon objects. Perfect. So we're going to say prop types dot object. And we're going to come back here. The way we check this is by making sure we don't have a warning. No warnings, we're good to go. We've set up our prop types correctly. Or maybe we set up our prop types beforehand and now we're passing in data correctly. But this still doesn't help, right? Like, what's our object? What does our object look like? What properties does it have on it? Okay, we're almost there. We're not quite there, but we're close. So if we can do an array of certain types, then we should be able to do something similar with objects. We could do object of, but that's only if every property is the same type, which is definitely not the case for our Pokemon objects, right? We've got all different kinds. So an object taking a particular shape. So this one looks like it's going to be a little bit more useful, a little bit more descriptive in our prop types here. So we're going to use shape instead of object in our array of. Now this is all very dependent on what your actual data looks like, right? So this particular setup is very particular to this data set. You're never going to have 2 data sets that look exactly alike, so you won't be able to come in here and copy and paste into other projects, even more than likely other components. Okay, so shape. Let's go look at how we set up shape. So this is a function call as well we pass in an object. Okay, so let's go do our function call and pass in an object. And let's go ahead and drop a line down on our object. So we've got the open braces up here and the closing brace down here. Now the way that shape works is we're going to pass in to this object the properties from the object that we're looking at. So let's go look at our data and let's take a look at the properties that we have here. So we're going to pass in, so we've got a lot of properties. Now what's really cool with prop types is you'll notice we've got a lot of data here, but we're not really using a lot of that data right now in our component. This is very much a subjective thing. You can choose however you want to set this up. A lot of companies in the world I've seen a lot of people do it different ways. So I don't think there's really a good set way to do this. This is kind of how you want to set this up. So we can just find what data we're using from these Pokemon objects. So we've got ID, image, and name, and only put those 3 fields inside our prop types object. So if you've got a situation like this where you've got a ton of data, but you're not really using a lot of this data, it's okay to come in here and say, I'm just going to do an ID, and I'm going to do an image and name. So let's set that up now, and then we'll go into this a little bit more. So let's go see what each of these are. I imagine they are all strings. Oh, ID is a number. Good. So ID is a number, name is a string, and image is a string. So I want you to take 2 or 3 minutes, and I want you to fill out this shape. So I'll do name for you. We're gonna call prop types again, and this is a string. We don't need to get any more specific than that. We don't need to say, there's nothing for a string that's like array of or shape. So go ahead and fill out these other 2. I'll give you 2 minutes. Okay, that probably wasn't 2 minutes, but we should be pretty close. Who wants to copy and paste this and share your prop types object with us? Ah, very nice. So Christian shared his. Sarah and Chad shared theirs. Awesome. Will, thank you. Yeah, these are perfect. So we expect these to kind of be the same because the data all looks the same, right? So 15 points to your Hogwarts house of choice. All 4 of you. Okay, perfect. So we've got array of for our array. We're describing what our array is made out of. We've got shape to describe the shape of our Pokemon objects. And then we're finally kind of getting granular to the data itself. Let's go double check over here that we don't have any errors or any warnings. And yeah, looks like we're good to go. Great work. Awesome. Let's change this to a string and take a look at that warning one more time. So if I make this a string, refresh, ruh-roh. That's embarrassing. Let's see, ID, Pokemon.id. If we do a number here, that will throw. Yikes, this is no good. Can anybody else see a warning coming up? Let's see, ID, image, name. object. Do I get a warning? No, that's not good. Okay, looks like a couple of you are getting warnings. Name, pop types, number. Okay. I may just have to refresh my code sandbox. And do that. All right, so props.pokemon is an array of objects with ID, image, name. Okay, so object. Va. So confused. Yarn restart. Let's see. We'll talk about is required in a minute. Shouldn't be causing this problem. Oh boy. Pokemon.prop types. Aha. Here's my problem. This somehow, because I grabbed this from Will. So Will, make sure you change your T to a capital T. There we go. So what was happening is I was putting this on the wrong property for my component, and then React didn't find camel case prop types, and so it didn't do any of the checking for me. So now, if I change ID back to a string, I should see that working. There we go. Okay, cool. So let's take a look at this one, because this is a little bit, just a tiny bit different. So, I mean, really the only difference we see is that it's looking at inside the array at a specific object or a specific number, and then looking at the field for that specific object in the array. So it's telling us that the ID inside my array, inside that first object in my array, the ID property was supplied to Pokemon as a number, but it expected a string, because we told it to expect a string, but it was given a number. So we come back here, and we say, oh, this is supposed to be a number. Ah, kidding me? All right, refresh. Connect it to live. Let's hide notifications. Pokemon. Make this a number. So now we should refresh and see, whoa, not new tab, and see no warnings. Cool. All right, so let's look at something a little bit different here. Let's come into our data, and let's say we want to add the type of Pokemon that each Pokemon is. I'm not going to build this out in the UI. You would have to map over Pokemon.type and then display the type individually. But what we are going to do is we're going to learn how to enumerate specific values that that can be held in our data. So enumeration means we are going to, Pokemon types are the perfect example for this, because there are a limited number of types of Pokemon, and you can't like have a different type outside of those enumerated values. So for example, there's no cloud Pokemon type, right? We've got a very specific list of Pokemon types. So when you have a specific list of values, and you'll never have a property on your data that is different than those specific values, we can tell our prop types object that. We can say that we're going to enumerate the only values that we ever expect on this in this data. So we're going to do this on the type property. And we're going to say prop types dot enum, enumerated values. So let's come see what we can do with enumerated values. Oh, just kidding, not .enum, .oneOf. I'm thinking of something completely different. There we go. So here's our enumerated value type checker. To one of, and it's going to be an array of strings. So let's just take a look at Bulbasaur. So we've got grass and poison. So let's pass both of these values into our enumerated array. So we've got grass and poison, but there's more than this, right? If we come back to our data and we look up another Pokemon that has a different type, so Charmander is of the type fire. So we should be getting a warning in our browser because we've told our prop types object only to accept grass and poison for this value. So let's go take a look. And there we go. Perfect. So we've got our warning. I'm going to refresh to get rid of our old warnings so we can take a look at this one specifically. So this says failed prop type, invalid prop type. So we're looking at the type on our Pokemon objects. Of value grass and poison supplied to Pokemon expected. Oh, let's see. Aha. You know what this, okay, this is tricky. Who knows what this problem is? We told it to expect grass and poison, and that's the warning that came up. You get 50 points for your Hogwarts house if you can tell me why this warning is coming up, and then we can fix it. This is kind of a tricky one. Oh, yes, Andrew and Benjamin, 50 points. Oh, and Josh, you said it as well. Perfect, yeah, it's an array. So we need to first specify, okay, so let's look at this. So what we're saying is type is a string, but it's not. We're telling our component to expect a string of grass or poison, but it's not, it's an array, right? So we need to tell it to expect an array, and then inside that array, we're gonna specify the exact values that can be included in that array. So how this works, how this will look is, let's just get rid of this line. So we're gonna say this is an array of, then we're gonna say prop types dot one of, and then pass in our array. This one's, the one of is tricky because this totally faked me out, even though I've done this many times. This still gets to me. So you pass in an array here, and like visually, I saw this array, and visually I saw this array. So it's like, okay, yep, we're good to go. And so that just throws, yeah, this one's weird. Okay, but we need to say that Pokemon.type is an array. Otherwise, we get into that issue that we just saw. So now we have grass, we have, oh, these are capitalized too. Since this is a string, we need to match it exactly, right? So we need to have capital letters at the front. Okay, so let's go see what error we're getting now. Ah, perfect. So we got past Bulbasaur, Ivysaur, and Venusaur, and now we're on to Charmander. So we got past the first warning we were getting. Now we're getting that the type for Charmander is fire, but we only told it to expect grass and poison. So there's one way we could do this to clear out this error. We could throw fire in here, save it, go look at the next error, and flying. And then we'd have to go one by one and keep doing this, keep adding these to the list until we don't get this error anymore. Or I could just pass you all the types that are possible here. There you go. So those are all the types that we should see in our Pokemon. So I'm going to save that, and then we should be past that error or that warning, and there we go. So enumerated values using .1 of, prop types .1 of. Now, if our data ever changed and we said you should be a cloud Pokemon, then we'd get that error again. And we'd have to go change our prop types object. So that happens. Your backend developers will change the data. Data will be updated and changed, and you'll have to go in and fix your React application. You'll have to fix your prop types because that kind of thing does happen. So fair warning, you're working with humans. Okay, awesome. Let's take one more quick break, and then I'm going to show you, we're going to talk about is required and the use cases for that. So I'll see you back in 5 minutos. Okay, here we go. Last part. Ben brought up a great question here. So could you go over what enumerated values are real quick? So we'll talk about that, and then we will look at is required somewhere in here. We'll find it. Okay, enumerated values. So I just did a quick Google search enumerated value, and I think this is a really good explanation right here. So thank you, Google. Enumerated type is a user-defined data type used in computer programming to map a set of names to numeric values. Not necessarily numeric values in our case, but prop values. Enumerated data type variables can only have values that are previously declared. So when we enumerate a value or we enumerate a data type, then that data that's coming in can only have a value that's been previously declared, like we see right here. So again, when we added Cloud to Charmander, then that we got that warning because that was not enumerated in our prop types. And then this last sentence is really good. In other words, they work with a finite list of values. So the Pokemon.type is not an infinite list of values that we could have in this array. These are the only values that can be inside our array. It's a finite list. So that's basically what enumerated values means. So great question. Thanks for bringing that up. Okay. Next thing we want to do is take a look at what is required. So in our data or in our components, we've got sometimes data is required, and sometimes you can render your component without that data and it'll still work. And that's pretty normal. So a lot of times, like maybe you're displaying a profile of clients, and you can click from client to client and display each client's profile, and maybe they've supplied a phone number and maybe they haven't, or maybe they have some documents and maybe they don't. So it's very common to have data that you're trying to display here that maybe isn't there. But there are times where you have to have that data in order for your component to display. And without that data, your component would actually break in production and development. So that's a situation that we want to avoid. So in the idea that we're documenting or we're telling the story of this component for future development work, whether it's us or another developer, we want to tell our future selves or that other developer which of these fields is required and which is not. So for example, let's go into our data and let's remove Bulbasaur's name. So we get to here and we see Bulbasaur's picture, but we don't have a name. And that's fine. There's no warning, there's no error. It works. It didn't break, right? So this is okay. So name is not necessarily required inside our component. Now we could say is required if we want to make sure that we have a name on every single Pokemon. We could say that their name is required. So for example, our client list, if we want to make sure that every client has an email, then we would say email is required. So let's take a look, and now we have a warning. So let's take a look at this warning. This is a tiny bit different than what we've seen before, so let's just read through it. We've got a failed prop type. The prop name is marked as required in Pokemon, but its value is undefined. So that one's a lot more straightforward than the other ones. This actually reads pretty normal. So in our first Pokemon, the name is required, but it came through undefined. Okay, so there's two reasons that we would want to use it as required. Number one is if it's a requirement that we show that data. So we don't want to open up this list and see a Pokemon without a name. And number two, if it causes an error and breaks the browser. So let's take a look at a situation that could be happening in. The live session is being weird. Sometimes it doesn't let me type. All right, so we're going to take off required for name, is required for the name. We'll go back into our data. We'll give Bulbasaur his name back. Name Bulbasaur. Bulbasaur. Okay, so Bulbasaur's got his name back. Phew. Let's take a look at our data, and we're going to now display this evolution array. And if you notice, our first object, so Bulbasaur here, has this property called next evolution. But if we look at our next object, if we look at Ivysaur, Ivysaur has previous evolution and next evolution. And then if we look at Venusaur, Venusaur only has previous evolution. So this is an example where if we said, well, let's start with next evolution. So if we said next evolution as a type here, so this is on our shape. When it gets really nested like this, sometimes you have to be a little bit tricky to find out where the next value is coming, where you put the next value. All right, so next evolution is, what is it? It is an array of objects with strings. Ooh, I'm gonna let you guys build this out just as an exercise to get a little practice building out some nested data. So build out the next evolution prop type for this array. So I'll leave this up on my screen so you can see what the data looks like. Actually, let's just close the browser and we can split this out over here. So there's the data, there's the prop type. And I'll give you 3 minutes. We'll come back in 3 minutes to take a look at this. Okay, we'll go 1 more minute. All right. I just posted a fun little thing in Slack. If you want to reply with what your favorite Pokemon is, you can reply on this thread. Or if you don't have a favorite, maybe you weren't a nerd like me growing up. I was pretty nerdy. So if you don't have a favorite and didn't grow up with Pokemon, find the one that looks the coolest and you can reply in our thread here. All right. Who would like to share what you wrote for next evolution? And then we can actually, if you notice in our data, previous evolution is going to be kind of the same. So copy and paste that here. Oh, nice. Got a lot shared. Okay, yeah, a lot of these are looking very good, very similar. Yeah, perfect. So we've got prop types.array of, because we've got an array, and then array of objects. So we want to do shape, right? So prop types.shape, and then num and name. Great, good job. Let me grab this. And we want to make sure that things are capitalized correctly here. By the way, Will and I planned that bug ahead of time. So that was not his mistake. Yeah, perfect. So these are both strings. We've got the number and the name. Nice. So let's do the same for previous evolution. So I'm just going to go copy, paste, and I'm going to say prev evolution, because that should be about the same. So we want to save that, and we want to take a look at, make sure we don't have any warnings. Okay, perfect. No warnings. But as we discussed, only some Pokemon have previous evolution, only some have next evolution. So if either of these were marked as is required, then we would get a warning. Because some of them don't have a previous evolution, like Bulbasaur or Charmander. So we need to be careful of when we're using is required. Now, even though previous evolution is not required, I can dig down inside of previous evolution and I can say that if a Pokemon has previous evolution, then both the name, the number, and the name are required. So I can say num is required and name is required as well. And I shouldn't get any errors from that. Okay, so do you see the difference there? If is required is on this property, I get a warning because not every Pokemon has previous evolution. But if I put it on num or name, every Pokemon that has previous evolution has to have these two values in that previous evolution object. So you can do is required on the nested values even if the property itself isn't required. Okay, very last thing. Let's say, let's find an example of something that, okay, yeah, let's say that this is required. Actually, we're going to remove these real quick and we'll say why we want this to be required. So we're going to take away, this is on Ivysaur. Actually, let's just work out with Bulbasaur. It's easiest at the top here. We're going to work with next evolution, and I'm going to take away the name of this first object. We're going to see why we want to tell, we would want to maybe say that name is required. And we want to make sure that every object has a name. So in order to demonstrate this, we need to build out our UI a little bit more. And I'm going to give you the code for this. Basically, we're going to map over, if a Pokemon has next evolution, then we're going to map over next evolution and display the name of all the next evolutions for that Pokemon. So we're going to do this right after the H3, and we're going to say Pokemon.map or Pokemon.nextEvolution.map, and this takes an array, I mean a function, and let's just drag this out over here. Okay, so Pokemon.nextEvolution.map takes in a function. It's going to return some JSX. So we're going to implicitly return some JSX with parentheses. And then we're looking at an evolution. I'm just going to call it E. We're looking at one evolution object per iteration in this map. And then for this, we're going to say, we're just going to do a P tag. And we're going to say evolution.name. Okay, but you see the squiggly lines here, we're going to have two problems with this, and we're going to solve both of these. So let's go look at what the error is. Cannot read property map of undefined. So why is this error coming up? Who wants to guess at what this error is telling us and why we have this? Oh, props.Pokemon. Okay. Yep, we need to do, oh, no. We don't need to do that because we're inside this map and we're looking at one Pokemon at a time. So this is looking at that, not at props.Pokemon. So we're okay there. So what is the error here? Not quite. Good guess though. No, we're not to the name yet. Good guesses. Okay, I'll show you. This was tricky, I'm sorry. So whenever you see this error, let me show you how to read this. This is saying cannot read property map of undefined. I'm going to zoom in a little bit here. So we come to map, and what this is saying is there's no property called map on undefined. So what's undefined? Well, whenever you see cannot read property something of something, you need to go to the left of this property. So next evolution is undefined here. And that's because not every Pokemon has next evolution, right? If we go down to Venusaur down here, there's no next evolution. So we can't run map on this third object because there's no next evolution. We can't do Evisaur dot next evolution or Venusaur dot next evolution dot map. Okay, so when you have some data that's possibly not there, well, first of all, as we discussed, we don't want to make next evolution required, right? Because not all of the Pokemon have that. So if there's a possible chance that this field isn't going to be there, then we need to block this code from running. So we're going to use a cool trick called, I always forget the name. I don't know what it's called. Someone can look this up and tell me what it's called. But we're basically going to say Pokemon.nextEvolution. Well, let's do it this way first. Let's do a ternary statement. This is just a fancy way to do an if-then statement. So if Pokemon.nextEvolution exists, then we're going to map over it and display all the names of all the next evolutions. Then, so this is the first if, and then this is the else block. Else, we'll just display null. So red squigglies are gone. Let's do this. Okay. Red squigglies are gone, and we are now displaying all the next evolutions of our Pokemon here. And some of them don't have next evolutions. Some of them have 2, some of them have 1. If we were to find Eevee, oh, they only list like 3. That's lame. So that's one way to do it. But if you ever find yourself, say, doing a ternary statement where the else is null, there's an even simpler way to do this. So take away the null and the colon, and we're going to say double ampersand. So what this says is, if this is true, evaluate this code. So if this ever evaluates to falsy, so if next evolution is not a thing on this Pokemon, then this code will never even get touched, and we won't see that error. Yeah, this is conditional rendering, but I forgot what, there's a specific name for this. Yeah, it's a logic gate, but it's, I don't remember. That's okay. The naming's not important. It's just a really cool thing you can do to block this from evaluating if next evolution is possibly undefined. Okay, so we see that situation, but now we have a problem where one of our Pokemon doesn't have a name for next evolution, right? So we want to tell any future developer that every Pokemon that has a next evolution has to have a name in that next evolution. So we're going to come here, we're going to say name is required and num is required. Dot is required. Okay, there we go. So now we should be getting a warning because one of our Pokemon does not have, the next evolution does not have a name. So this is a point where you can say is required so that another developer that passes in the wrong data to this component will see that warning. So then we go back to Ivysaur or to Bulbasaur, and we put next evolution, the name for the next evolution back in. And then we should have that error cleared out. We're mapping again, so we need to, the warning we're getting now is on this map. This should have a key inside here. E.num should be unique. Okay, there we go. Any questions? Let's take a look at Slack, see if there's any questions. And yeah, then we'll take a look at what the project is for today. Okay, sweet. Yeah. So two names for this: logical and short circuiting. So this is a technique called short circuiting, where we short circuit this line of code from running by doing this. Thank you for finding that. Awesome. No questions have come up yet, so we'll go over the project for this week. And if you have questions, we'll check one more time. I'll check one more time on Slack after that. Okay. Go all the way down. And we've got React InstaClone. So you will clone this down to your machine, and you'll get it up and running once, and then you won't have to do that again all week. So you're going to be working on the same project all week long. You're going to be committing and pushing code to the same repository, and you can do, I think what we're going to do is new PRs for each day, but so that your PMs can be checking your progress there. So React InstaClone project. The purpose of this project is to continue building on your knowledge of React that you've gained so far. These first 2 days, there's not a lot that goes into this project. There's not a lot that we're learning in lecture that goes into this project. These first 2 days, you're going to be learning new things, and you will implement those, but you're also going to be doing a lot more of rehashing what we did last week. So you'll be building out components, and you'll be rendering stuff in the browser from those components, and then you're going to be doing a lot of set state logic just to get extra practice at that. Read through the introduction, get an idea of how this is going to work this week. You will come into this, and from this file here, you'll run create React app, and you'll create a React application inside that folder that you cloned down. The project setup goes over that directly, so those instructions are there. Then you have your tasks for each day under the task headlines. Then this is what we're building. So the data for this project is 3 Instagram posts that look something like this. So you've got your post, you've got a picture, you've got the user who posted it, how many likes they have, and any comments that each post has. So you'll make a header for your project. You'll make a list. You'll render a list of posts, Instagram posts, and then each post will look something like this. And then there's going to be stretch problems each day. Each stretch problem is kind of, some of the stretch problems each day are going to be, go learn tomorrow what we're doing tomorrow and implement that into your project today. So some of the stretch problems each day are going to be just getting you further ahead in this project. Just heads up there throughout the week. So you'll notice that we've got 4 readmes. You've got the readme, which is day 1, and then day 2, day 3, day 4. And just a warning, I know that there have been many people that have found the solution branches in these projects and maybe even relied on the solution branches a little bit too much last week. These solution branches for this particular project are pretty far behind. We've iterated on this project quite a bit, and just so you know, the solution may not match what is being asked in the instructions. So just fair warning there. There was kind of a problem with a different cohort where they were looking at the instructions and they were looking at the solution and they couldn't put the two together because they're different. And they were really mad at me for some reason. Like, it's not my fault you're looking at the solution. You got to work on this yourself. The instructions are there. Do it. Anyways, I got a kick out of that. I hope that you recognize that if you're relying on the solution branches for projects, that you're not growing and you're not learning what you want to learn in this program. So please, please, please don't. The solution branches are there to show you how we would implement a project, not to give you the answer before you try it out. It's just like working out. When you lift weights, you're tearing down your muscles so that they can grow stronger. When you go through these projects, if you don't go through the pain and frustrations of not knowing and having to look up things and ask questions, then you're not breaking down the muscles and you're not growing stronger as a developer. So again, you're just hurting yourself if you rely too much on the solution branches. All right, enough preaching. Any questions on the project? And then we can cut loose. Okay, so we fork clone, then run create React app. Yeah, fork clone CV into the project you just cloned, and then run create React app. New branches each day. Yeah, you can kind of set this up how you want. You can do a new branch each day, or you can just do a new PR each day. Work with your project manager to decide how you want to set that up. Okay, awesome. Hey, you guys are amazing. Good luck today. Good luck this week. Wednesday with higher order components is weird and hard, but we'll get past that next week. I can't wait for next week. It's my favorite week in all of the React units. So let's work hard this week, and yeah, I'll see you all tomorrow. Have a great day.